Hello everyone, welcome back guys. Hope you all are doing well. This is Mohammad Badruddin back again with another video, and in this video we are not going to solve this lab, which is the next lab in the CSRF vulnerability module. Although we are going to see some concepts here, and the concepts related to same site cookie attribute, which is very important for this topic and for this lab to be solved. So there are a few points which are very interesting and very important for you to understand it, and will be able to differentiate between terms which normal people or normal professional use interchangeably, and we will see that in a minute. So I'm going to scroll up, and we will start it by bypassing same site cookie restrictions. So before understanding how we can bypass, it is important to understand what is same site cookie attribute. Fine. So what happened before, whatever request we made, even in the same site or same origin or out of band to other sites and other origin, in each and every request, the request contains the user session cookies and other cookies. Fine. So in 2021, Google applies the lax same site restriction by default if the website that issue the cookie does not explicitly sets its own restriction level. So basically, this same site cookie attribute is a security feature in the browsers that help control when cookies are sent along with the request, and it helps mitigate the cross-site request forgery, cross-site scripting, cross-site leaks, and core exploits. Fine. So the same site cookie attribute contains three values. The first one is lax, which is by default used by the Chrome browsers. Other values are like restrict and none. We will come to that point in a minute, but before going to that point, we must understand what is site and what is origin, and what is the difference between these two, because normally people use site and origin interchangeably. So we are professional and we must understand the difference between these two. So this is the structure of a URL, let's say, and here this .com is the top level domain. You can say TLD, which stands for top level domain. So .com, .net, these are the top level domain, and before this top level domain, first level is known as domain name. So this first level and this top level domain contains the domain name. Fine. And this HTTP and HTTPS, this is known as schema. Fine. So what is a site? A site contains a domain name with the schema. You can see this is the schema and this is the domain name that contains a site. So let's see, there is an example, http://app.example.com, and if we compare this to https://app.example.com, so in these two there is only one difference, which is this schema within the schema. So if we compare these two, you can see there is a difference in schema, so that is known as cross site. So these two are not the same site, so we can call it the cross sites. Okay, so if we don't want our session cookie sent within the request while we are communicating cross site, at that instant we will use the same site cookie attribute. And even if you do not use and you are using Chrome browsers, or other browsers also use the same thing, like by default it's using same site attribute with value lax. Now we come to the origin, and what is the difference between origin and site. So origin covers everything with schema, subdomain, domain, and the port number, but the site only contain schema and the domain name. So even if the schema or domain name is changed between two sites, that means the site is different. And in origin, everything must be same. So there is a chart where you can make the comparison to just check your knowledge, whether you understand things correctly or not. So you can see, let's say your application is requesting this domain to this domain. So you can see schema is same, domain name is same, so the site is SameSite, yes, and the origin is also same, because there is no change in the schema, no change in the port, no change in the domain name. So this is the same site and same origin. Now let's move to the second one. So the schema here is HTTPS, and we are requesting to this that also contains HTTPS. Subdomain is app, and the domain name is example.com. And here where we are sending this request to is having a different subdomain name, which is intranet. So as you can see, if we talk about the same site, so same site must contain same domain name and same schema, which is perfectly can be seen here, that schema is HTTPS, same as this one, and also the domain name is same. So the same site is yes, but the same origin is no. So this is, you can see there is a same site and cross origin. Why? Because the domain name is mismatched, because origin also check the subdomain name. Fine. Let's move to the other one. You can see here this is the same as above, but here where we are requesting contains the port number 8080. So you can see, because the site will only see schema and the domain name, which is same, so this is the same site, but the origin is different because the port is mismatched. Fine. So you can see the origin also check the port. Similarly, you can also check these two. I will move forward. Okay. Now, how does SameSite works? So before the SameSite mechanism was introduced, browsers sent cookies in every request to the domain that issued them, even if the request was triggered by an unrelated third-party website. So SameSite works by enabling the browsers and website owners to limit which cross-site request, if any, should include a specific cookie. So that's what I mentioned earlier, and this can help you to reduce user exposure to CSRF attack and all. I already mentioned it before. Now you can see there are 3 values of the SameSite cookie attribute: restrict, lax, and none. So lax is used by default by the browsers. Fine. So developers can manually configure a restriction level for each cookie they set, giving them more control over when these cookies are used. So you just need to include SameSite attribute with set cookie in the within the response header. Okay, like this. We did it, and we see it in the previous 2 labs. Okay, this thing is very important. This is not the overall mitigation of the possible threats. Fine. So although this offers some protection against CSRF attacks, none of these restrictions provide guaranteed immunity. So this is not the guaranteed solution for against the CSRF and cross-site scripting attacks. Okay, so let's see about the strict. So if you define SameSite cookie attribute as strict, this is basically the most secure option with the SameSite. So if a cookie is set with strict attribute, browsers will not send it any cross-site request. This means that if the target site for the request does not match the site currently shown in the browser's address bar, it will not include the cookie. Fine. Let's move to the lax. So lax SameSite restrictions means the browser will send the cookie in cross-site request, but only if these both conditions are matched. So what are these conditions? The first condition is the request must use get method, and the second is the request result from a top level navigation. Top level navigation means user click a link manually. Okay. One more important part here, as we see the first condition, that the request must have the get method. So this means that the cookie is not included in cross-site post request. For an example, as post requests are generally used to perform actions that modify data or state. So that's why you must have get request method for using the lags. Okay, and none is, as well as the name is concerned. So if a cookie is set with the same site attribute none, this effectively disable the same site restrictions, although regardless of the browsers. So as a result, browser will send this cookie in all the requests to the site that issued it, even those that were triggered by completely unrelated third-party sites. So this is all about the SameSite. I would highly recommend you to read this and go through this content one more time, so you will understand more better, and if there is any gap you can fill it by reading it. Now because the next lab is about bypassing the SameSite lags restriction, so this is important to understand, although we will see these payloads in the real lab. Okay, one thing is important here, which is this part, because you can see sometimes if you have post request and you convert it or change the HTTP method from post to get, but even though explicitly you need to define the method to post, so you need to see what framework you are using or what framework is used in the application, like Symfony, Laravel. They use you can explicitly define the method by defining underscore method parameter in the form, which takes the precedence over the normal method for routing the purposes. So here, if you can see this form, you can find out that the method is mentioned here post, but explicitly it is defined within the input field method is get. So if you define a method explicitly, it will take the precedence over this method within the form. Okay, so that's it for this video. I hope you understand the concept of using SameSite cookie attribute. In the next video, we are gonna solve another lab based on SameSite cookie restrictions bypassing. So that's it, and I'm gonna see you in the next video. Bye.